Hello, I'm Miraj. Today I will explain how we use knowledge graph templates with LLM-RAG. But first, let us go through why we are using this. So consider you have a very big private data and it contains a very complex relations and key concepts of your data is spread here and there in the entire data set. In that scenario, if you use the LLM and RAG based technique, traditional RAG based technique, then your system will not give the good response. Consider another scenario. Suppose you have multimodal inputs. Some pieces of your inputs are coming from text, some pieces of your input are coming from videos, images, and speech. In that scenario, even if you convert all those information pieces into text format, it will be very tough to combine the information spread in all different pieces which are coming through the different types of resources. Another scenario is also there. Suppose you have entire data that is coming from the text resources, but it is a heterogeneous text resources. Like some data is coming from the text, traditional text. Some data coming from tables, HTML file, XML file, program outputs, program comments, codes, and so many program documentations, and so many different data sources, which looks like a text, but it is heterogeneous in nature. So in that case, the informations, pieces of information in those data will be so highly scattered that if you just use them as a RAG, then your system will not be able to give the appropriate answer for your query. So in that case, we use the knowledge graph templates. Actually, knowledge graph templates provides the direct relationship between nodes and entities or between entities. So generally we represents the knowledge graph templates as entity 1, entity 2 and the relations between them, or we represent it like a subject, predicate and object. So let us go through a simple example. Suppose we have a simple text related to beer, that beer is a carnivorous mammals, and a lot of different informations are that we collected from Wikipedia document and collected here. Now if we try to convert entire information spread here in the form of some knowledge graph templates, then it will look like that. Sorry, then it will look like this. So what is beer? It belongs to relations classified as, also known as, number of species. So many such relations are possible. Now the next part is how we can get such kind of knowledge graph templates from our data. So there are a lot of different ways that we can apply and get such information. But here I will just explain how we can get through directly LLM, large language models. So I directly use the Olama package. So you can download the Olama package from the official site for Windows, Linux and your system. Actually my main purpose is to use the offline generation of everything, and for large language models you can select any of those large language models that you want to use. I had used Llama 3. So for that you have to just run this command. It will automatically download and store it in your whole directory which is related to Olama. So once you have ready with all those things, you can take these documents. Then you can join all the information spread in different sentences into a single text format, and then you have to write one simple prompt if you directly want to generate through large language models without anything. So prompt is like give the list of all knowledge graph triplets for the following text \n and then single dot means the entire text. And once you run this prompt, it will generate the result. So after some cleaning, you can directly use it. So here I have generated the knowledge graph triplets for the entire text. Instead of just depending upon the Llama 3, I have combined 2-3 packages available here and collected the maximum possible outcomes. So that's why it looks a little better here. Now the next part is after generating the knowledge graph triplets, how you can use it. So what is the process to use it? So to use it, you have to follow this process. So first, your big private data source. I am considering that I have converted the entire data into private data, into text data format. After that, the next task is to get the knowledge graph triplets. So that knowledge graph triplets we can directly collect through large language models, or you can apply some other algorithms that is publicly available. So it depends upon which is best applicable in your scenario. So once you get everything, the next task is to embed the text. For the text embedding, I have used the BERT large based embedding technique strategy. This embedding actually converts the all such kind of triplets into vector format. For example, suppose beer is there, so it will convert those that into some like this. So again for R it will generate one vector, and for this part again it will generate some vector. So that way it will generate the vector, and we store all those things in a vector database. So here the vector database is very important. Now the next part is query. So here like what you want to know from the large language model in the context that you have generated here and stored in the vector database. So the approaches are like either extract the triplets from the query also, like you have extracted from the dataset. Next is like if you have some more ways to extract the meaningful relations from the query, that you can do, or if you have nothing, you can directly use your query text. So 3 options are there. You can have multiple more options also. Once you get finalize, so in our case I have directly used the query text, I didn't make any change, and then apply the text embedding, same text embedding that used here, and then file the query. It will give the highest cosine similarity scores informations. It will collect those informations and give those information as a context. So those extracted triplets we store it in the form of data. And next is like a query. So query, we already extracted the query in the form of prompt and then we embed it. So we use both data and prompt and query it, and then large language model will take both information and answer your query. So this is the process. So I will explain that how it is working here. So in this case you can see that I have used the ChromeDB as a vector database, use the same documents, but instead of generating the knowledge graph triplets, I have used the generated triplets that I generated here to save the time. The next part of the query is how to simplify these triplets. This is very important. So we have to convert the triplets into text. So how to convert? For example, bears use shelters as dens. So we use those and just remove the comma and added a space so that it looks like a simple text fragment. So we converted all the triplets into a text fragments. After that, we have created a database here. Then inside the database, we created the collection, and the name of collection is beer kg, and then we have added the metadata just like a cosine similarity type of things, nothing else. So for each triplets that we have here, kg triplets, we have called the embeddings, and for embedding we have used the BERT large text embedding that you can got from here. By running this code you can directly download it, and it will store in your Olama directory setting. So we first simplify all the knowledge graph triplets and embed them, and then append them and stored in the collection, that is your vector database. The next part is to take the prompt and also apply the same embedding for the prompt. So as I did here. So once it is complete, we apply the query. So in the query, we want 3 knowledge graph triplets which can serve as a best context for this question, like how does the bear's body look. So the prompt is like a very layman kind of question. So once we get that, we have just printed our results and the entire collections. So entire collections means what we have embedded. We just wanted to see that what kind of embedding is stored in our system after running that embedding system. And we also printed the result, means what is the result of this query. And after getting the results, the next task is how to use that result as a context, because we are getting 3 results. So the process is like we can concate all the knowledge graph triplets one after other. So this is the process. Like if the length of supported documents means in the results the number of triplet is just 1, then take 1. Take directly that. If it is more than 1, then append it. And then now we use that Olama generator, Olama.generator, to call the model Llama 3, and we pass data as a context, which is nothing, just knowledge combination of knowledge graph triplets that we extracted through the query and the prompt. Now when we run this, we will get the exact output. So let us run and see what happens. Now it seems the system has generated the complete embedding, and it printed the results also. Means the results shows that which queries are matches with our questions, like how does bear's body look. So it identified the matching triplets, like bears are classified as caniforms. Bears have an excellent sense of smell. So looks okay. Now here you can say that embedding is none. Why it is none showing? So actually what happens, all the ChromeDB kind of packages or vector database packages, just to save the time, they don't show the embeddings in the outcomes. But if you want to see the outcome, embedding values in the outcome, you have to use this collect.get, and you have to use this include embedding documents metadata that you want to see in your result. If you add those things, you can see. That's why in print it is not there, but in the entire collection outcome it is there. So here you can see that embedding for each of the knowledge graph triplets. So all those 3 knowledge graph triplets will be used by our system as a context to get the answer for the query. Our query was, how does the bear's body looks? So let us see what it answers. I am surprised to see the speed of this system. Even in just a 16 GB RAM system, I quickly got the result. So The results are like it says that interesting facts about beer active during the day, given that. So it has given some interesting fact about the beer. So first is like so just to go through the summary part. So what it says based on our context. Quote: diurnal beers quote would likely to have blend with its daytime, means how it is working with daytime, what are the things that he got, that beers got to work in daytimes, how his eyes, body shape, wow, it covers everything, other features depending upon the species of beers. So it has provided a sufficient amount of information about the beer, and finally it gives the summary also. I think this is a very good outcome and very quick outcome in a offline fashion. And so thanks for watching.